let us discuss about the lesson adding probabilities. Right now I'm trying to show the ways of doing these kind of problems. Perhaps if you have any further question, you might ask me later on after I'm done with this. Determine whether the events are mutually exclusive or not mutually exclusive. Let me review a bit on these two terms. Now, when this is the two events together, that's why we call adding probabilities. If the event 1 and event 2, if the two events, the elements of the two events are overlapping, then they are not mutually exclusive. But if the elements in each of the two events are not overlapping, then you call the two events are mutually exclusive. Now, to understand furthermore what it means by these two terms, let's look at number 1 and part A together. Two cubes are rolled. Two cubes are rolled. Okay, each of the cubes have 6 sides or 6 faces. So when you have two cubes together, so possible outcomes of the 6 times 6 will be 36. So the possible outcome which is 36 overall. Now they said find the sum of 10 or double. Let me give you a better understanding of how it looks like. Look at this one together. These are dice, or we call cube, number cube or so. And this, we have two forms. It's either this form or this form. Which one you think easy for you to do? You can follow this one with me. In dice form, in this one here, 1 1, or in this one 1 1. See, they represent with the dice and with the number cube. It all 36. 1 2 3 4 5 6. 1 2 3 4 5 6. So 6 times 6 36. So possible outcome 36. Now find the sum of 10. So you just simply get the sum of 10. So sum of 10, as you can find from here, like this one easy to see. 3 6 7 8 1. So we have here 1, sum of 10. This is sum of 10. Sum of 10. And sum of 10. So that's our first part. Sum of 10, we have 3. And then second part, or double. Okay, double, we have this one as double. We have this as double, 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 and double. Okay, so look at this number here. We have 5 here, 5 5. It is a double. It also a sum of 10. So it seems like these two events are overlapping because they share common elements. The 5 5, it is 10, and also it is double. So once they share common element like this with the two events share common element, then you call this as a not mutually exclusive. So our answer, not mutually exclusive. And how to solve this problem? You just as you know together is the possible outcome is 36. Overall 36. So just simply count all of that together. Count all the elements in each of the two events. So the double, we have 1 2 3 4 5 6. And for the 10, you have 1 2, because this one you already counted. So 6 and 2, you have this as 8. So 8 over 36, you simplify it. 8 over 36 simplified, you will have 2 over 9. So you will have 8 over 36 or 2 over 9. Okay. Now for part B, you do the same thing. Find a sum of 6. You find the sum of 6 that plus together can make 6, And then find a sum of 7. You try to find a sum of 6. And then you try to find a sum of 7. Try to find it. So once you find all the elements together, and then you combine. You see first, they have the element that overlap each other. Like the first number, the element that overlap is 5 and 5. It is 10 and it is also double. So it's overlap. It makes this as a not mutually exclusive. But for B, if you cannot find any element that is overlap, then it will be mutually exclusive. I do believe that it is mutually exclusive, because it seems to me that the sum of 6 cannot overlap with the sum of 7. So answer in this case is mutually exclusive. And to find its probability, you need to find this one by yourself from the counting right here. Find the sum of 6 and find the sum of 7 plus together will be over 36. So I will not do this part for you. You need to count it by yourself. Let me give you the example. Let's say sum of 6. You have 1 here in this section. This is sum of 6. Sum of 6 also. Sum of 6 also. So you do the counting, you know, and the counting and plus together, and then you list it down how many times it has. And then sum of 7, you have 1 here, 2, 3, and you continue counting. You will have 1, you combine the two terms together, elements together in each of the event, and then overall over 36. And you just simply simplify it, you will get your answer. Part C, sum less than 3, so which means that 2 and below. Less than 3, 2 and below. You have 1 here, which is less than 3. Or greater than 10. Okay, greater than 10, you have 11, and you have 12. So you try to combine the elements together. You know, if you have overlapping elements, then you just then the first answer will be not mutually exclusive if it has common element, which means they share the same element in some parts. But if they do not share any common elements, then it will be mutually exclusive. Once you answer those part of the question, then you find its probability. Of course, it's over 36 together, over 36. Now, among 36, how many of them belong to less than, sum less than 3 and a sum greater than 10? And you combine the elements in each of this event, and it will be over 36, and you simplify it. Let's go to number 2. A card is drawn at random for a standard deck of cards. Okay, then a standard deck of cards, you have 52 cards. So just keep in mind 52 cards. 52 cards, in case you might not know. 52 cards, that's for standard decks of cards. And among 52, you will have 13 diamond cards, 13 club cards, 13 spade cards, and 13 heart cards. So together we make 52 cards. Part A, find probability of club or diamond. Club or diamond. This is a mutually exclusive because the element in club do not overlap with the element in diamond. So you just simply 13 from here plus 13 from here over 52, and you simplify it. Okay, it's 52, and you have 13 from clubs plus 13 from diamond, and then when you plus, you get your answer over 52, and you simplify it. Now for ace or spade, this is a not mutually exclusive because there is ace in spade also, or there is a spade in ace. You know, we have a spade also inside this element. So this is overlapping element, so it is a not mutually exclusive. So to find the answer, in this case, you have to minus one of the elements. So which means that you have 4. Let me write this one first. 52 cards in all. You have 4 ace, 4 plus 13. So 4 plus 13, but you need to minus 1, which is overlap. So we have only one overlap space inside here. So 4 plus 13 minus 1. When you get your answer, will be over 52, and you simplify it. Let me repeat. There is one element in this overlapping situation, which is an ace of spade. So there's one element alone. So 4 ace plus 13 spade, and you minus 1 spade ace. So 4 plus 13 minus 1, and you have your answer put up here over 52, and you simplify it. The jack or red card. Okay, this is also an overlapping element inside it. So it is a not mutually exclusive, because there is also red cards in jack, or jack has red cards also. So that's why it is an overlapping. The card that is red for jack, we have a diamond of jack, or jack of diamond, and jack of heart. The two cards are red. So this one over 52. Let me remind you again, this is a not mutually exclusive. So to get the answer for the probability, 4 plus this red card, you have 26 of them, because you have diamond also red, and diamond also red, and heart also red card. So therefore you have 26 of them. So 4 plus 26, and you minus 2. Once you get your answer, you put as a numerator and you simplify it. Let me repeat. 4 plus 26, and then you minus 2, and you put as a numerator here when you get your answer, and you simplify it. And you might ask why minus 2, because there is 2 cards overlap with the red card here. We have jack of diamond, which is red, and jack of heart, which is also red. So that's why 2 cards overlap with this part. That's why minus 2. That's why 4 plus 26 minus 2. And once you get your answer, you put as numerator and you simplify it. Number 3. You have 10 freshmen, 8 sophomores, and 2 juniors. Of these students, 9 freshmen, 2 sophomores, and 1 junior are female. Now, student is selected at random. Same idea. Is it exclusive? Is it mutually exclusive or not mutually exclusive? For the first part, and then find its probability. Freshman or female? Okay, this is an overlapping event. So you call this a not mutually exclusive. To get the answer, let me try to find the total number of students first. 10, 8, 2. So you make together 20. So overall 20 students. So let's see how many over 20. Freshman, which is 10, plus female, which is 12. So you have 10 plus 12. We need to minus the overlapping student as well, because a while ago we are overlap. So freshman overlap with female freshman. 9 female, then also freshmen. So it seems like 10 freshmen here, and 9 freshmen are female. So this is the overlapping part. 9 of them in this situation. So we have 9 students overlap. So freshman 10 plus female 12, and then you minus 9. When you get your answer, you put as numerator, and then you simplify it. B. Sophomore or female. Sophomore, and again it's still over 20. Let me try to sophomore and female. Okay, you have sophomore, you also have a female sophomore, so they are overlapping. So this is also a not mutually exclusive because of the overlapping event, which is have 2 females overlap with sophomore. So sophomore will be 8 plus female, which is 12. Yeah, 12 female. and then you minus overlap female, which is overlap student, which is 2 sophomore overlap. So let me repeat for you to understand a little bit more on that. Sophomores have 8 plus female 12 and minus 2. So 8 plus 12 minus 2. Once you get your answer, put as numerator and you simplify it. C. Part C. Freshman or sophomore. So freshman or sophomore. Seems like they are not overlapping at all. Freshman by freshman, sophomore by sophomore, no overlapping in this part. So therefore, this is mutually exclusive because they do not share any common elements. So freshman, which is 10, plus sophomore, which is 8, and then over 20. So freshman 10 plus 8 give you, 18 over 20, and you simplify it. You will have 9 over 10 in this case, I think. Number 4. A card is drawn from a standard deck of cards, which is 52 cards, Find odds in favor of drawing a heart. Then find odds against drawing an ace. Alright. Odds in favor, odds against. Let me try to briefly review a bit in simpler terms what odd against and odd in favor. Now probability, define probability is what you want over everything. Like in this case, what you want over everything, which is 20. But when you find odd in favor, what you want over what you do not want. And for odd against, what you do not want over what you want. Let me repeat. Finding odds in favor, which means you get what you want over what you do not want. So you want heart, so what you want heart over anything that you do not want. So it's not going to be over 52 anymore, because if you find over 52, it's going to be probability. But this you want to find odd in favor. Okay, so odd in favor, first section first. Odd in favor of drawing heart. What you want is a heart. So you have, instead that deck of cards, as I mentioned before, you have 13 heart. And over what you do not want is not 52, because all is 52, and among 52 you want 13 is what you want, and the rest is what you do not want. So 52 minus 13, you have this one as 39. So this is a odd in favor of drawing a heart. So 13 over 39, and you simplify by yourself. Now for odd, find odd against of an ace. Against ace. So when you find odd against, what you do not want over what you want. So what you want is down here. So you want ace, we have 4 ace. And the rest is what you do not want, which is, so to make 52, which is 48, I believe. So once you get 48, and you simplify with 4, and then you have your answer. So make sure you write your answer as in simplest form. Number 5. Number 5, 2 fair coins are tossed. Find the odd in favor of both landing on heads. Then find the odds in favor. It's all in odd in favor. Odd in favors of exactly one landing on tails. Okay. Let me try to give the first section first. Okay, let's try to give you this one. This is the possible outcome when you have 2 coins, head, tail, tail, head, or tail, tail. As I mentioned before, odds in favor, what you want over what you do not want. First section, you want both landing on heads. So both landing on heads. So it seems like you have only one. So 1 over what you do not want, 3, because among is you have 4. You have 1, you want this one already. So the rest is what you do not want. 1, 2, 3. So 1 over 3. That's for odd in favor of both landing on heads. And then the next section, then find odds in favor of exactly one landing on tail. One landing on tail. So again, what you want, which is one landing on tail, you have 1 and 2. So you have 2, and then the rest is what you do not want. 1, 2. So it seems like you have 2 over 2 or 1 over 1 in this part. Last number, number 6. And again, look at the question. Find the experimental odd against it, odd against, then odd favor again. Let me try to find this part. This is altogether 120 times, and odd against of 6, of 1 or 6. So let me try odd against what you do not want over what you want. You against 6, you against 1 and 6. So it should be down here, 1 and 6. So you have 1, 16. This is, and then you have 6, 8. Together you will have this as 24. So you have 120 minus 24. You have this one as 96. And then 96 over 24, and then you simplify that to the simplest form. Then find the experimental odds in favor of rolling a number less than 3. Okay, in favor this time a number less than 3. You have 24. So this is a number less than 3. From here down to 1 here. You have 16 of 1, 24 of 2. So plus together you will have this as 40 over what you do not want, which is 80, to make it 120. Once you have that, you simplify it into simplest form. So this is the complete explanation of lesson adding probabilities. I hope this will help you a lot in doing your work. So please be sure to watch the video so that you will not get lost when you do your work, or perhaps sometime when we have tests during the week, you will know how to do it. Lesson 0-6, multiplying probabilities. A number cube is rolled twice. Find each probability. This is a previous lesson 0-4. When you add, the term they use is to use the word or in the middle. But right now we're using the word and, so which means it is a multiply. 1 and 3. So when rolling a cube is when you roll a cube 1, you get 2, and you're rolling a cube another time. The first time you roll a cube, you got 1. You get number 2. Second time you roll a cube, you get number 3. So how do you find the probability of rolling the cube twice? So a cube has 6 possible outcomes from 1 through 6. So first roll 1, you have 2, you get number 2. So among the 6 faces, you have only one number 2. So over everything, which is 6. That's our first roll. And which is multiply. Second roll, of course, a cube has 6 faces. Second row, you get number 3, and also has only one number 3. So 1 over 6 multiplied by 1 over 6, and you get your answer by yourself. Simplify it. Now this number 2, you roll twice, you get 2, 4, which means you roll the first, you roll in, you get 4 and 4. It means another term. Probability of getting 4 and 4. So you still have 1 over 6 multiplied by 1 over 6. So it gives you 1 over 36. Next question number 3. No 6. Okay, which means you get any number but not number 6. So which means that the first row gonna be 5 over 6. Second row gonna be 5 over 6. You know why? Because it's any number but not number 6. So you have 1 through 5. So 5 over 6 multiplied by 5 over 6, you get 25 over 36. Number 4. Find probability of two of the same numbers. Okay, 2 of the same number. Let me give you an idea of 2 of the same number. I think you will have this as a 1 and 1, and you have 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. That is the possible choice that we have from the term 2 of the same number, which means the first row you get 1, second row you also get 1. You get 3, 3, 5, 5, 2, 2, and so on, so forth, which means the 2 row you must get the same answer. So let's work on this number. Let's work on the this number first. So first row 1 over 6. Second row 1 over 6. So you have 1 over 6 times 1 over 6. You have 1 over 36. Now if you repeat this one with the other, because we have 1 over 6, 1 over 6, 1 over 36, 1 over 36, 1 over 36, 1 over 36, and 1 over 36. So 6 times. So to get to the final answer, which is probability, you just simply get 1 over 36. You multiply by 6. You will have 6 over 36, and you simplify this by yourself. I hope you are clear with this section. Let's move down further. Okay, if you're looking at the question, looking at the problem up here, a bag containing 8 blue marbles, 6 red marbles, and 5 green marbles. 3 marbles are drawn one at a time. Find each probability. Looking at the instruction up here, it's just simply like, just simple probability. What you want over everything, just like up here. No, it's not going to be like that. Because they use the term given or if. So this will give you we call conditional probability. This is the formula for this. P of this event. So to get this event, given that, second marble green, given that, so you have 2 events together, event A and event B, multiply together, and then you divide by the first event. So by looking at the formula, somehow it's kind of hard to understand. But try to apply formula within the problem so that you will have an idea how to do it. So place the formula right here, and then let me bring out my scratch paper to help you along the way with the problems. Let's do one at a time, please. Number 5. Second marble is green given that the first marble is blue and not replaced. So you have even A, which is, you have, look in the problem, we have 2 events. You have even A and you have even B. Now even A, now everything, wait, let me try to plus this one together first. 14, 19, so everything is 19 together, 19. So even A, which is in this number 5, even A, or the first event, which is blue. So you will have this as blue, which is 8 over 19. That's for even A. For B, even B in this case is the green marble. So together, and since it's not replaced, so it's gonna be over 18 because not replacing it. So 8 over 19, and blue in, oh sorry, even B, this is green, so 5 over 18. So when you multiply this together, which means basing on the formula, the even A, 8 over 19, 8 over 19, multiplied by even B, which is 5 over 18, 5 over 18, and then you divide this by even A. So you divide it with even A, which means you divide by 8 over 19. So here it is. Alright, and you press equal, you have 5 over 18. So that's our answer to the first part of this probability, which means in number 5, 5 over 18. Let's move on furthermore to number 6. Number 6. This is the formula to give you an idea how to follow it. Second marble is red, given that the first marble is green and is replaced, or is replaced. So let's give the first event first. Find the first event. First event, green marble, which is 5 over 19. That our first event. Second event, which is red. So red, you have 6 over, this is replaced, so 6 over 19. So to do the work, formula A, this even A, multiply the even B, and then you divide by even A. So you just simply do the multiplying of fraction, multiply by 6 over 19, and then you divide by 5 over 19. That will give you 6 over 19. Let me adjust the light for you. So 6 over 19 is for number 6. Now look at number 7 together. The third marble is red, given that the first two are red and blue and not replaced. Okay, it seems like you might get lost in this section, I think, because right now they are up to the third marble. But do not get confused with that. Please stay focused with me. Alright, so let's try to distinguish even A and B first, because our even has only two even. It's either A or B. So even A, which is this first section here, see, given the first two are red and blue and not replaced. So for even A, you have two together, combine two together to get the even A. So red and blue and not replaced. So red, you have 6 red, so 6 over 19 multiplied by blue, which is 8 over 18. Notice that these two still belong to even A. Let me simplify this one together first. What will be the answer to this part? So 6 over 19 multiplied by 8 over 18, because it's not replaced, will give you this as 8 over 57. This is the even A. Even B, which is the third marble, is red still, and it's not replaced, so it's over 17. And red before it's 6, but since you draw only, so you draw one red out already, one red out, so another red gonna be a 5 over 17. So find the answer with this problem: even A times with even B, and then divide by even A, you'll get your answer. Let's do this with me. Even A, 8 over 57, multiply by even B, which is 5 over 17, and you divide by even A, which is 8 over 57, will give you the answer as 5 over 17. 5 over 17. Number 8. Number 8 is the same idea like number 7. 2 red, but this is are replaced. So okay, so it's always over 19. It's always over 19. Okay. Even A first. Let me try to find even A. Even A, the first two are red, so you have 6 red over 19. Still 6 red over 19 because it said replace. Let me simplify these two together first to get an even A. So you have 6 over 19 multiplied by 6 over 19. You have your answer as 36 over 361. This is for even A. Now for even B, the third marble is green. Okay, green, which is 5. So you will have 5 over 19 since it is replaced. So to get to the final answer, even A times even B divided by even A. Even A times even B divided by even A. So you have a 36 over 361 multiplied by 5 over 19, and you divide by even A, which is this number, will give you a 5 over 19. Okay, for number 9 and number 10, looking at the given up here, there are 8 black, 3 red, and 5 white shirts in a class set, and they select 3 shirts at random from the class set. Find each probability. Number 9, yeah, they select 3 black shirts, which means black, black, and black with replacement. So the total numbers of the shirt, you have 16. 8 plus 3 plus 5 is 16. And to get this answer with replacement, all black, so you have, since it is with replacement, the possible outcomes stay the same, which means you have 8 over 16 multiplied by 8 over 16 multiplies again by 8 over 16, and then when you simplify it, you will have 1 over 8. For number 10, 2 black, then red without replacement. So the possible outcome will change, as you can see from here. 16 go down to 15, go down to 14 because without replacement. Once you get it out, it's already out, not put it back, so it's going down. The first black, 8 over 16. Second black, 7, because you already take 1 black out, so 7 over 15. The third draw is red, 3 over 14. And you multiply this together and you simplify it, you will get your answer by yourself. I will not use this answer. Number 11, you draw a card from a standard deck of cards. As you can see, I already told you before, a standard deck of cards, you have 52 cards. The friend tells you that the card is red. Okay, so it seems like you will not guess from 52, but you will guess among the 26. Because among 52 cards, there are 26 red cards. So what were you guessing? What is the probability that you correctly guess the card is the ace of diamond? Alright, So among the 26 red cards, you have only one ace of diamond. That's why 1 over 26. 1 ace of diamond among the 26 red cards. For number 12, suppose the probability of a student taking AP calculus, or we have calculus and honor roll. Okay, these two events together, calculus and honor roll, is this probability. And then the probability that the student is on the honor roll is 0.23. Find the probability of a student taking AP calculus. Alright. So this is the way they give you even A and B already. Calculus and honor, this is the value they give to us, and then they give you one value also, which is the, let's say, even A, this value, and the missing another even B. So this is the form of calculating to find the missing probability. PA and B, they are already given. PA also given, missing PB. So to find the probability of a missing event here, missing probability of this event, when you solve this equation, when you transpose this one to this side, you have 0.0035 will divide 0.23. You will have your answer is about 0.015. I hope you follow. Let me repeat. This is the form of equation. To get the missing probability of even B, you simply transpose this number to this side. So you will have 0.0035 divides 0.23. You have this answer. Number 13. For number 13, this is the table that shows us status pass or fail, class or no class. Looking at this section together here. A, I will not read this instruction up here. You might want to read this one by yourself, but I'm going to read the table and then looking at the question. A, look at the given first. That's the keyword. Look at the given first. The given, she took the class. So the given took the class. This section took the class. So a total class, total number of took the class, you have 64 plus 18. We will need this one here. So totally is 82. And she passed. So in taking the class and she passed, so passed 64. So you will have 64 over everything which is 82 in the class section and pass. So class section 82, she passed 64 over 82. Simplify this and get your answer by yourself. B, look at the given first. She did not take the class. Did not take the class. Okay, this did not take it. So 48 plus 32 to get the total number of not taking the class. You have 80 on this section. She failed. Did not take and fail. So you will have 32 over 80. And you simplify this by yourself to get your you get to the simplest answer. And then C, looking at the given first. Given that he passed. Okay, pass. So this section here for pass. Pass. 64, 48. 64 plus 48. 112. Looking at the first part, Jamaica did not take the class. Okay, pass, did not take it. So 48 over 112. 48 over 112. You simplify it and get your answer by yourself. Let's go to the last number in this section. Right, it's the same idea. Looking at the table and using the same term, given that, you know. So just follow the same style. A, look at the given first. Given that he is male. Looking at the male section. Male. 156 plus 242. 242 to get the total number of male, which is 398. And the first section of the sentence here, a student is a member of a club. So male, member of a club. So you have 156 over a whole thing, which is 398, and you simplify this to get to the answer. B, given that she is female. Okay, female, looking at the female section, female is all female. 312 plus 108 equal to 420. A student is not a member. Okay, female and not a member. So you have 108, it's not a member, over 420. And make sure you simplify this to get to the final answer. Part C, the last section of question number 14. Given that he is not a member of a club. Not a member. This is not a member of a club in this section. So 242 plus with 108 to get to the total number of not a member of a club. So you have 350. That's for everything in this section. The student is a male, okay? Not a member and is a male. So you have 242 over 350. Again, not a member of a club and is a male. 242 over 350. 242 divide 350. I give you this one as the bonus. 121 over 175. Please be sure to watch this video for you to understand more with this problem. I think you might get lost a lot within this problem if you do the work by yourself. You can looking at this video referring to the number you think you need more understanding, or you can discuss with your friend for further explanation.